kind of forehand speech. Yes. It's my pleasure to introduce these two speakers from France, the colleagues Emmanuel CHAILLEUX and Flavien-Geisler. Few notes about them. I know that Emmanuel will start, then Flavien will continue, and then again to Emmanuel to conclude. So we have a bit more time for them. But again, I will let you know when the time is finishing. And since 2004, Emmanuel has been in a permanent position as researcher in what we all know as IPSTAR, and now is Université Gustave Eiffel in the Materials and Structure department. His investigation is mainly focused on the bituminous material performances, binder performances, including rheological properties and the viscoelastic modeling, aging, cracking phenomena, and development of alternative binders from biomasses. He's chair of one ReLEM technical committee, the one devoted to phase and interface behavior, if I'm not wrong, while Flavien is a project manager, PhD, in road and pavement engineering, working at IFAG within the research and innovation department, if I'm not wrong. Okay, from 2015 to 2020, worked as a manager in the 5th generation road project. This sounds very futuristic somehow. And as a background as a chemical engineer, so now he works as project manager in the field of chemistry of bituminous binder, and biobinder and bio-based emulsion. So welcome to you both, and please take the stage.
So thanks a lot for the invitation. You could hear me? Okay. Flavien? Yeah. So during this presentation, we will try to answer to the following question. Could bio-based binder be an alternative to bitumen for pavement construction sector? And we would like to give an answer from the academic point of view, so me, because I'm from the University Gustave Eiffel, and from the industry point of view.
Me?
Yes, Flavien. Flavien, please introduce you.
Yeah.
Okay.
Yeah.
He's from Eiffage.
Yeah, from Eiffage. Yeah.
Okay. So we will divide the presentation in two parts. The first part will be more or less an introduction on the subject, trying to answer to several questions about the possibility to replace bitumen by an alternative product coming from biomass. And in the second part, Flavien will expose some products made at Eiffage and made at industrial scale. So the first question: why we need to find an alternative to petroleum bitumen? I think it's a very important question, and lots of people have this question in mind, especially no. No. So I strongly think that is linked to the future of fossil resource exploitation. And the first thing is the ratio of the stock of oil and the demand. In some scenario, we know that we are more or less on this on a peak, and so the demand will decrease, and the stock will decrease also. So it means that it is still a competition between this demand and this stock. We know that now we are more and more electric car, so we can imagine that the demand will decrease, and the demand decreasing, this industry will have economic problem. In fact, because the investment is huge in this industry, and if they have not the possibility to sell enough bitumen, this industry could collapse. In fact, it's a scenario. And we know that we have some bitumen shortage at the moment, especially during summer in France. The second thing is the future regulation. For example, at the European level, there is an initiative, the Euro 7 initiative, which this initiative tried to regulate the CO2 emission from oil combustion. So we can imagine that in some years, we need to reduce the CO2 emission from oil combustion. So it means that the demand of oil will decrease due to regulation. And there is also another type of regulation is what Camilla explained is the CO2 market. Yes. And the other thing is the petrochemical refining strategies. And we never know how the oil company will do in the future. For example, they can crack all the oil to make energy, to make fuel. And in this case, we will have no more bitumen. So all this item lead us to think about alternative regarding bitumen. So what alternative is needed? We can divide in two parts for partial replacement and for total replacement. So for partial replacement, it could be extender. So we put between 25 and 75% of a new material in bitumen, but it could be also rheology modifier like fluxant, rejuvenator, or biopolymer to give structuration to a bitumen. And it could be also surfactant. Eiffage has some patent on biosurfactants to make a bioemulsion, for example. And depending of this material, the consistency of the biomaterial will be very different. It could be consistency close to bitumen, but it could be also liquid or elastic solid. But of course, the main goal is the total replacement. And concerning the total replacement, so it could be in virgin technique with virgin aggregate. So in this case, the consistency need to be like bitumen, in fact. But it could be also associated with recycling techniques. And it is very interesting in this case because it gives the possibility to design a biobinder according to the old bitumen on the reclaim asphalt. We can optimize the design, which could be very interesting. It is what we have done in the biorepavation project, for example. So the problematics are very complex, in fact, because we need, if we want to replace bitumen by a bio-based material, we need to have enough availability of this biomass. We need to take care of the competition between this biomass and food. We have not to put food in road. I think you agree with that. Like, for example, vegetable oil. We prefer to have a vegetable oil in our salad than in our pavement. But we can use waste cooking oil. It's another solution. The other problematic is how to transform this biomass. Because of course we can use, for example, a vegetable oil like this. We need to increase the consistency or to decrease the consistency if you want to make a rejuvenator, which is already made with esterification. So we need also, the problematic is also to design this type of binder according to the use. So I already mentioned this, full replacement, partial replacement, or additive. And what it is very important also is the physicochemical properties of this new material. We know perfectly bitumen, we know all bitumen age. We almost know how to age bitumen in lab, even if it's not completely understood. And we also, what I forget to mention is also the environmental impact of this new material. We know the environmental impact of bitumen, but we need to take care of the environmental impact of the new material we will put in the world. I have an example if you want at the end. So concerning the biomass availability. So in the world, we consume 111 million tons by year of bitumen. So we have to replace all this quantity of bitumen. It's a very huge quantity. We can imagine that we will recycle more, and perhaps in the future we will it will be mandatory to recycle at 50%. And in this case, we can divide by 2 the binder demand. It's the first thing. We can imagine that we will decrease the consumption of bitumen. So if we are looking the quantity of biomass available, you will see, as Camilla showed us in the last presentation, that it could be compatible in terms of figures. For example, the production of vegetable oil is 2 times the production of petroleum bitumen. And if we can use this vegetable oil after use, for example, waste cooking oil, it could be a solution. But there is also other solution, like residue from agriculture. You can see that the agricultural fresh residues production is huge, 3,300 million tons by year. And we have also other type of residue from forest, and which are very huge. Of course, it can be used like that. We need to transform this biomass, like the sugarcane bagasse, for example. But we see that in terms of availability, it could be possible. It could be, of course. It's an hypothesis. Concerning animal biomass, for example, tallow, we have to think about it because it's perhaps not ethic to put animal in pavement. But we can have this discussion. For me, it's non-ethic to put any animal in pavement, but you can have a different opinion. And there is also a potential future biomass, which is not produced at in a large amount at the moment. Is microalgae. I work a lot on microalgae these years, and it could be the future of the biomass, in link with biofuels also, or protein production. But it doesn't exist at the moment. So concerning the recent development for full replacement of bitumen, you can see here some patent, but I certainly forget patent because it's very difficult to find all the patents there. But you can see that several types of biomass are used. We can find the resin, vegetable oil. We can also find cellulose and some other biomass coming from chemical process like pyrolysis and hydrothermal liquefaction, and of course lignin, sugarcane bagasse, once more, or tall oil from paper industry. There is also hemoglobin. There is a patent with hemoglobin from slaughterhouse. So I let you have your opinion about that. Okay. So I will finish in some minutes. So at the moment, at industrial scale, for total replacement, pine material from pine chemistry is mainly used, and also co-product from paper industry, from the craft process. I don't know if you know the craft process, the process to produce paper, and there is a byproduct which is highly used at the moment to produce bio binder. So there is also vegetable oil from the vegetable oil refinery process, like Cargill, Dawn, or other type of industry. And there is also other type of biomass still at the development stage. And in this case, it is needed to transform the biomass from the solid state to a liquid or semi-liquid state. And we are studying a lot, for example, hydrothermal liquefaction. It is a process where we try to liquefy the biomass using hot water at 300 degrees at high pressure, 100 bar. But there is also pyrolysis. And at the moment, we are working a lot also on the modification of waste cooking oil. So I will finish by this slide showing you some patent and some material patented used in France, developed by a French company, FH, Colas, and Eurovia, so the vegetable Shell, vegetable Sequoia, Florafalt, and Biofalt. They are all based on the same concept. You have dispersion of resin immersed in vegetable oil, and the resin structure the material, giving viscosity to the material. And sometimes in this pattern, they had a polymer coming from oil industry. So you can see the oil here, which is produced, which is a clear oil, which has the same rheology as bitumen, in fact. So, up to you, Flavio.
Thank you, Emmanuel. As mentioned, I am working at FH, and as an industrial player, I will try to introduce you the bio-based range that we are developing since more than 20 years ago now. This range is based on the tall oil chemistry. So, as already mentioned, tall oil come from the forest, is a forestry byproduct, and especially coming from the pine refinery. And these products have many advantages. The first one is a very good compatibility with bitumen, and it has also very good rejuvenating properties to rejuvenate the hard bitumen coming from reclaimed asphalt pavements. Another interesting thing is its negative carbon footprint due to the biogenic carbon storage, thanks to the growth, the photosynthesis and the growth of the tree. So what do we do at FH with these tall oil derivatives? So our bio-based range is currently composed of 3 products. So 1 emulsion, similar to a bitumen emulsion, and 2 binders. So first, the recital emulsion is composed of more than 50% of tall oil pitch, water, and you need some acidic component to adjust the pH and, of course, surfactants. Biofalt is a binder with bio-based content higher than 90%. and BioClair is at least 45% bio-based. From Jason. So Recital emulsion is dedicated for cold recycling at wrap content, which is 100% wrap content in place or in plants. But we have developed a dedicated machine which is named ARM. And on the picture, you can see the in-place recycling job site is working. So first, you have a big tank with which is containing the Recital emulsion, and it contains also water to adjust the water content of the material. Then you have the ARM, which is a big milling machine with a specific down-cut process to optimize the gradation curves. And just behind the milling drum, the Recital emulsion is added, and the material is conveyed directly into a paver, a conventional paver. And then there is a completion step, and that's it. You can open the road to traffic. So it's 100% wrap, just a few percent of this bio-based emulsion. There is no need to transport the materials from the site to the plant and from the plant to the job site. So it's very environmentally efficient. So can few words about the MIG design with this kind of technique. So we have to discuss with contractors, and the language of contractors is standard. So we refer to a French reference guide, which is entitled Call-in-Place Recycling of Old Pavement. And you have a table with a direct comparison of laboratory study with two mixes, two cold mixes with 100% wrap. Just you add an emulsion, so a bituminous emulsion or Recital emulsion, and with the same binder addition, content addition. So if you look at the results, you can see that the air void content of the specimen and that the resistance to combustion in air are much lower for Recital than for the bitumen emulsion. But however, the resistance to combustion in water is similar. So we have a ratio higher with Recital than for the traditional bituminous emulsion. And on the right, you have a picture of a trial section. In one lane, it was in-place retreatment with a bituminous emulsion, and on the other lane, you have the in-place retreatment with Recital emulsion. So visually, there is no big difference because of the color of the bitumen coming from the wrap. It's black. So yeah, we have several references. Currently, we have paved more than 500,000 square meters with this technique. So I have two examples on this slide. The first one is the highest traffic that we can reach with this kind of technique, because with cold process, you can have much heavy good vehicles on these sections. And yeah, so the first section is the departmental road 670. It's between Toulouse and Bordeaux. And the retreatment was 2 kilometers long, and the thickness of the retreatment was 9 centimeters in this case. On the other hand, on the second example, the traffic is much lower. The thickness was just 6 centimeters, and the length of retreatment is about 1.5 kilometers. And with this machine, with the ARM, we can pave 1 kilometer of lane a day. So it's very efficient. Let's move to the biofalt mix. So biofalt mix can us to reach higher. It's adapted to all level of traffic and all weather condition. So biofalt mix is made with a few percent of biofalt biobinder, which is 92% bio-based, and we still need a high wrap content, more than 30%. In average, we are at 40%, but we have experiments up to 70% of wrap in the mix. I have to mention that we are manufacturing warm mixes because you don't have to heat too much the biobinder. It is thermal sensitive, and in terms of formulation, we adapt to the experiment. So we are doing the design regarding the European standard. So the commercial development started in a few years ago, right after the bio-repavation project, because biofalt was tested on the APT facility of University Gustave Eiffel, and it was a very long-lasting product. Yeah. Thank you. So some examples. So we can reach a different level of traffic. You have an example on the left on a French motorway. It is a wearing course with a 40% wrap. So usually the contractor don't want wrap in the wearing course in the top layer. Only it's allowed only for base or binder layer. But in this case, yeah, we have to add wrap to have the good rejuvenating property and the good synergy property with our biofalt binder, and that's why we convinced him to do this trail section. It was done in 2020, so we have more than 1 year of background, and it behaved quite well at the time being. The other on the right, there is an experimental section followed by the French Transportation Administration Technical Services, the CEREMA. And in this experiment, we have 4 sections. So we would try biofalt as a base in the base layer or in the top layer, and we compare with traditional hot mix. So we have a combination with hot mix in the base and surface layer. We have a section with biofalt in the surface and base layer, and then we have a top layer with biofalt and the base layer with a hot mix, and the contrary. So the experimentation is still ongoing, but it behaves also quite well. And yeah, we have made more than 20,000 tons of biofalt mixed in the past few years. The last product is BioClear, which is a clear and permeable surface course. It is only dedicated for soft mobility. Our clients are cities who want to fight against urban heat island phenomenon and against the impermeabilization of the soil. So the demand is more and more increasing for this kind of product. Yeah, the last point is the environmental footprint of these mixes. So in France, we have a tool to compare several mixes at the mix design step. It's called SAVE. And so you have an example with a Swiss solution comparison. So 15 square meter pavement, 6 centimeters thick, and 3 solutions. So the first one is hot mix asphalt, which is around 90% on the French market. The first option is in-plant retreatment with a bituminous emulsion, and the second option is the in-place retreatment with a vegetal emulsion, recital. So some indicators, so in terms of non-renewable aggregate consumption, so you are close to the 100% because you use 100% of wrap. The energy consumption of the process is decreased sharply between the option 1 and 2 compared to the reference, because we are comparing cold process to a hot mix process. And if you look at the CO2 emissions, you can see that for the recital pavement, you can have a decrease which is more than 100%. So you can see the carbon sink effect of the tillol which is contained in these products. Emmanuel, I let you conclude.
I was sleeping. No. So to conclude, I think we have exposed some motivation to perform long-term research for in order to find alternative. I think it's necessary to work on this subject at the research level and also at the industrial level. I think using biomass to make bitumen could be environmentally beneficial, especially concerning the carbon sequestration. We can speak more about that. At the moment, for example, waste cooking oil are used to make biofuel. So it means that CO2 come into atmosphere. Finding an alternative to this waste cooking oil by putting this material in pavement gives the possibility to store carbon. And I think it's the best argument for this type of material. So we have seen that some full-scale experiments have been done on its work in the carousel of the University of Eiffel, but also on the actual site. It's worked. I think the best thing could be to mix the recycling techniques, so to take profit of the old bitumen in reclaimed asphalt, and also in the same time using renewable material. It means that we consume less bitumen, and and we reuse old binder. And I think it could be in the future the best way to make road. Yes. So it's the conclusion. Thank you very much.
Thank you.